This lesson is for Mrs. Cucci's College Now Pre-Calculus class. Today we're going to be talking about the inverses of matrices. So we do have two objectives that we're working towards. The first objective being able to find the inverse of a square matrix, if it exists, and using the inverses of matrices to solve systems of equations. This lesson will be broken up into two different videos, day 1 and day 2. So the first thing we need to talk about is how we will continue to study matrices by finding multiplicative inverses and determining if the inverses of square matrices exist. We're then going to use those matrices to solve systems. So that's the overall goal. So first we have to be comfortable with understanding what an inverse matrix is. So an example of an inverse matrix, or an identity matrix, let's talk about that first, would be that of, let's say we have 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. That's an example of an identity matrix. And you have seen this in the past video, so this should be nothing new to you. Okay, so let's keep moving. Why it doesn't go with it? Very strange. Okay. So, example 1. We have matrix A and we have matrix I. So we're going to write down what those matrices are. Okay, so matrix A is a 2 by 2 matrix. 4, -7, and -3, 2. And then our identity matrix, also 2 by 2, would be 1, 0, 0, 1. Okay. So what we're going to do is we're going to determine A times I, so matrix A times the identity matrix, and then we're going to determine I times A, so the identity matrix times matrix A. So we're seeing if indeed this is an identity matrix, so we're kind of proving that. If we multiply something or a matrix by the identity, we should wind up with the matrix A. So that is the overall goal. Okay? So, let's first do AI. Okay, so we're going to write A and I side by side, matrix A, matrix I, so that we can perform this multiplication. And we have 4, -7. Ooh, yuck. Just kidding. -3, 2. And then, of course, our identity matrix, which is 1, 0, 0, 1. And the multiplication, when you're doing this multiplication, an easy way to think of it is you want to do the first row, and then you're going to go down the first column. And then you're going to do the first row down the second column for your top, okay? So first row down the first column, right? So you should have 4 times 1 plus -7 times 0. So first row, first column. Now first row, second column. 4 times 0 plus -7 times 1. Okay. Now for the bottom row, you're going to do second row down the first column and then second row down the second column. So -3 times 1 plus 2 times 0. And then -3 times 0 plus 2 times 1. So let's find the sum of these. 4 times 1 is 4, plus -7 times 0 is 0, so we get 4. 4 times 0 is 0, plus negative 7 times 1 is negative 7. Negative 3 times 1 is negative 3, plus 0 is negative 3. And negative 3 times 0 plus 2 is 2. So we got 4, negative 7, negative 3, 2, which is A. So 1, 0, 0, 1 is indeed that identity. Okay. So now we're going to do this for IA. So we're switching that order here, and we're going to see if that works as well. Right? So IA, we're switching that order. So identity first, then the A matrix. Perform the multiplication, first row, first column, first row, second column. So 1 times 4 plus 0 times negative 3, little space here. 1 times negative 7 plus 0 times 2. Oops, and I'm trying to squeeze it in here. Second row, first column, 0 times 4, 1 times negative 3, and 0 times negative 7, 1 times 2. When I do the addition here, I get 4, negative 7, negative 3, 2. So as you can see, that worked for both of those. Okay. So multiplying by that identity is commutative. It doesn't matter in which order you multiply. Okay, so the next thing we're going to talk about is how we go about finding inverse matrices, okay, or verifying that two matrices are inverses of one another. So we're going to start by looking at matrix B, which we're saying is 4, negative 3, 3, negative 2. Oops, just hit that with my hand. And we want to show that it's the inverse of A, which is negative 2, 3, negative 3, 4. Okay, so we want to show that B is the inverse of A. So what we're going to do is we're actually going to find the product of matrix B and matrix A. So I apologize, but I'm going to have to erase this. So if you need to pause it now. Okay. So we're going to find the product here. So we're going to have BA. I'm going to put them side by side. A. We're going to find that product. So again, we said that it was first row down first column, first row down second column, right? You have to get that order in your head. So first row down first column, fix. 4 times negative 2. Hold on. It's not like me today. Four times negative 2 plus negative 3 times negative 3. And then 4 times 3 plus negative 3 times 4. Second row, first column, 3 times negative 2 plus negative 2 times negative 3. 3 times 3 plus negative 2 times 4. And then we find the sum here. And we get negative 8 plus 9, negative 12 plus 12, negative 6 plus 6, and then 9 minus 8. Finish that up, and we get 1, 0, 0, 1. So what we wound up with was that identity matrix, right? What that means is that A and B are indeed inverses of one another. Okay? So that's the goal. That's what we're looking for to have happen. Okay. Okay, so now let's talk about how we go about finding the inverse of a matrix. Okay, so I have matrix A, which we said was -2, 3, -3, 4. And I want to go ahead and find the inverse. Okay, so what I'm actually doing, and this is going to be long, so I apologize in advance. What I'm actually doing is I'm looking for this in conjunction with that identity. Okay, so we're going to rewrite it as an augmented matrix. -2, 3, -3, 4, in conjunction with my identity, 1, 0, 0, 1. So the goal is to get this to be over here. Okay, so we want to use operations to kind of adjust it so that that left-hand side becomes 1, 0, 0, 1. So the first thing I'm going to do, if we're looking to get things to cancel, is how about we go ahead and take row 1 and we multiply it by half, by -1/2. Because if I multiply that by -1/2, that -2 is going to become 1, right? So I'm going to do -1/2 times row 1. And that's going to give me 1, -3/2, -1/2, 0, -3, that doesn't change, 4, 0, 1. All right. Well, now that we've got that, what we can do is, how about we take and we look at adjusting this -3. We'd like it to be 0. So what if I multiply row 1 by 3? Because if I multiply row 1 by 3, it's going to allow me to add row 1 and row 2 together to get a 0 in that spot. So row 1 times 3 becomes 3, 9/2, -9/2, my apologies, -3/2, 0. And then row 2 is -3, 4, 0, 1. So let's go ahead and do row 1 plus row 2. And remember, I adjusted that row 1, so it is going to go back to what it was prior to my multiplication. So that goes back, row 1, -3/2, 1, -3/2, -1/2, 0. I'm adding these together now, right? 0, -1/2, -3/2, 1. My writing is atrocious. Yeah? Come on. Okay. So I've got a little bit further now. Now I have my 1 and I have my 0, but I need to work on the -3/2 and the -1/2, right? So let's take and do row 2 times a -2. If I multiply row 2 by a -2, it's going to give me a 1 in that place, right? So my 1 stays, my row 1 stays. And this becomes 1, 3, -2. Okay, so we're a little further. Now we got to work on that -3/2, right? So let's multiply that -3/2. Well, we need it to be 0. So if we take row 2 and multiply row 2 by 3/2, I'm able to then add 1 and 2. So 1 isn't going to change yet. Row 2 is going to become 3/2, 9/2, and -3. Now I'm going to do row 1 plus row 2, 1, 0, 4, -3, and then this row 2 is going to go back to what it was here, right? Before we adjusted it, 1, 0, 3, -2. So now if you look here, this is exactly what I wanted. Okay, so my inverse is what's on the right hand side. 4, -3, 3, -2. And I think that is enough for today. I apologize for the horrible handwriting. I'm trying to get better at this as we go along. Okay, so please come prepared with any questions that you might have, and I will see you all tomorrow.